have a couple generic announcement-y things. So tomorrow from 9 to 9:30 in this room, and Thursday from 9 to 9:30 in this room, we have dean candidates that are going to be here. So if you have open time in your schedule and care, I guess, or want to learn or hear about the new potential dean candidates for the College of Computing and give any sort of feedback, I would encourage you to attend those times. So 2 different people, Dr. Chung and Dr. Trenhill, will be visiting. So FYI, that's why I was starting with like random things going on. The other nugget is for Thursday, that immediately following this, they're also usually doing other things in this room with that candidate. So they haven't found us a spare classroom yet. So I don't know what we'll be doing on Thursday, if we'll have class or if I'll just post a video on some stuff. So heads up as to that going on. So I don't know if anyone's ever gotten to like listen to a dean candidate presentation before, but they're usually somewhat interesting. So that and this slot, or those 2 slots, are specifically for when both these fellows want to meet with students and talk with them. So
can I assume that's the evening?
No,
This morning?
it was in the morning. Yeah, yep, 9 a.m. Hence the immediately following. There's some other session in here that takes our classroom from us. The other one I was going to mention is this is in the activity post, and since I've just been getting bombarded with emails about it rather than just letting you email me, I was just going to talk about this. So I have a couple grants that I have gotten for starting this summer for a few different projects. The one is actually like a cybersecurity workforce grant. So you'll notice this little deal popping out, I think, in the activities post today about an internship going on, or I don't know if we'd call it like formal internship, but basically it's like a paid job with DSU over the summer. Hosts, it should be, I don't know, 6 to 10 people, not quite sure how many, but be working with myself and a few other faculty. And we're not like, what we're actually doing as a part of the workforce development thing is there are some, dare I say cyber, because that's a stupid term, but security related topics that DSU does in a rather hands-on fashion with all of these, whether it's playing with cell phones or reverse engineering software or whatever it is, or like blowing up computers with Metasploit. A lot of universities struggle with that. So what we are doing this summer is creating, as a part of this project, is myself, some faculty, and some student helpers will be basically creating like lessons and labs and stuff like that for us to give out for free to other schools to try to help them get started. So like as a just kind of random example, if you, I don't know, you probably had a class where like in the book there was a lab for you to do, and the teacher's like, do lab 3 at the end of chapter 7 or something like that. Well, the teacher actually has a lab guide that goes through, generally speaking anyway, that goes through and tells them how to set up the lab and what all you need and stuff like that. Well, when you look at most of the labs we have here on campus, at least in the computing majors, like I've dreamt them up on my own, or Josh dreamt them up, or Ham made them. We didn't like get them out of a book. So we don't have a lab guide for any of our stuff because I know how to set it up because I set it up. Or in the case of the lab that you're doing right now, I screwed up setting it up. You know, either or. So basically coming up with like hands-on kind of activities for people to play around with and learn stuff, and then actually a lab guide to help a teacher that maybe doesn't know this stuff that well get the lab set up and running. Like if a teacher is going to set up a firewall lab, but the teacher themselves, he or she has never actually set up a firewall, they're going to need some help, right? So that's what's going on with that. And then the other part of this is Gen Cyber. So there's a couple camps we've applied for. The ones I've applied for have been funded. So we'll have a week at a time. We'll have 200 high schoolers here. So 400 high school students will be here on campus. So if that sounds like a good time, that's also a part of this too. So help out with that, whether it's herding chickens from one point to another or making sure that we haven't, like, Oregon Trail lost a couple along the way at night in the dorms and stuff like that. So, and come up like some activities that might actually be fun to do with a group of 20 high school students or so at a time. So the actual Gen Cyber Week, like, you have to be there for that, but otherwise things will be fairly flexible. Like if you're like, I want to take 4th of July week off, like, yeah, that's fine. Or I want to take this random Friday off to do X, Y, or Z. Stuff like that is all cool. So there's a link that will be in the activity post, so check that out and apply for it if you care to. I'm not necessarily the person that's going to be selecting all of them, although I sign off on all of them, so but with the faculty that are involved, they're going to go through the list of people that have applied and be like, yeah, I think you would be great fit for this or something. So, so I guess that's like the please don't wear out my doorway asking, like, have you picked yet? Because I'm not the one picking. But anywho, so that's going on too. Any questions on that? Nothing? All right. So where else am I? Let's do this. So there is a lab that we have out here. Couple pro tips. Well, first of all, there's one configuration item that I screwed up on when I pushed it out. There's a note in D2L about it, but I was going to show you it now just so you're aware of how to fix it, because I made a typo. So in the Juniper firewall, if you come in here and go to, like, in edit mode, if you go like edit routing options and show, there's a static route I've put in there. That is so that the GOAT network, which is using NAT, can get to dog, which is not using NAT. So in order for that to actually work, it needs a route in there to figure out how to route its way there. And I knew that ahead of time when I pushed the lab out. The problem is I just put the wrong route in there. So that doesn't work so well. So what you would need to do is go delete static route and just hit that. Or maybe you have to identify, I figured I would just delete them all. There we go. Delete static route. The one I actually have in here is correct already, but you need to delete the static route, and then you'd go set static route 64, and you can just do 0.0.0.0.0/8 next hop 24.220.181.102, which that is the IP address of the Palo Alto firewall, or that should be on the WAN, so it should know how to get there. You can also edit this in the GUI. If you're frantically trying to write down the command, it's, I believe, pasted verbatim in D2L, so you can grab it from there too. So, does anyone have any other questions on this? Nothing. That makes me nervous. So, FYI, this isn't one that, like, you start midnight the day before it's due, unless you're, like, really good at this. But if you're really good at this, you're probably not going to start at midnight before it's due. You probably just, like, are going to quick go do it. So it will take you some time, and I won't have a lot of sympathy if you're like, I spent 3 hours on this and I still don't have it done. I'm like, yeah, it's going to take a little while, because there's 2 different whole sets of firewalls you have to configure, and you have to make sure you don't make a typo or anything like that. The other one is when you're assigning, so you have to go through and configure every one of these interfaces. And for, like, the Palo Alto one, I told you to just set an IP address that should be the appropriate default gateway in this range. So what would that then be if I tell you to set an IP address? Like, say we have something like this, where I gave you 64.43.242.0 and said set an appropriate IP address for the interface. What are you going to configure the interface with? Yeah, you'll configure it with 64.43.242.1 slant 24, depending on your firewall and stuff like that. So if you set it as .0, for example, I've actually had a couple students do that already and email me with questions or stop by Help Night. Is that going to work? Yeah, that's not going to work. The other one is, since all of the servers that are out there, their networks are pre-configured and whatnot, so if you decide to use something weird as the default gateway or as the interface to the IP address, that's not going to work either unless you go into the servers and change their config, which you could do, I guess, but instead you could just set the IP address to be whatever is appropriate to use. So remember my other tips in general, since the Juniper network, or GOAT, is using NAT, you need to make sure to do destination NAT for outside stuff to be able to visit it. Just like if you at home were hosting a server, you would do destination NAT for the internet to be able to get to you. But what if you want to go out to the internet? What's the other part you need? Source NAT. We make sure to configure source NAT if the assignment says, from the GOAT admin machine, browse the dog server. Well, that's twofold, right? When you go from the GOAT network to the dog network, is the dog's firewall the only one you're concerned with? No, you keep in mind that although this other firewall needs to allow the traffic in, you need to have let your own traffic out first. So that means in the case of the Juniper one, or GOAT, that you have a source NAT rule and firewall rules that let the traffic go out. So pro tips to help you out with that. What are other questions that I've had? Yeah.
What is the kind of issue setting a static route? It's just telling me that the IP address that I'm trying to set the next hop to is invalid.
You're typing an invalid IP address, I suppose. So you've got so you're getting the IP address is invalid, huh?
Yep.
24.220.181.102?
Yep.
You're not doing like slant 32 or anything on there?
Nope.
I don't know. I'll do one of these advanced moves. And let's look, and then we'll all see what Josh has going on. So we look what we got going on. So set static route 64.0. I don't know. It just sort of worked. Oh, no. No, yeah. See, now we'll publicly ridicule you. So I took a screenshot just purely so that I can zoom in. Because it's hard to see on the projector screen. It's even hard to see on my screen. Yeah, you had a comma right there. So not to just make fun of Josh, but there's part of that too. But keep in mind that when you're setting these up, it's when it comes to configuring stuff, part of what is frustrating about this in general is that you can't get close, right? And Josh is just a comma, so it's just a typo. But like, if you get the IP address close, is it gonna work? No, it's not like any different than like your math class. If you're doing a derivative and you got the answer close, but it's still wrong, wrong is still wrong. But in this case, wrong means it's not going to work. So, like, usually, and back to the comma, that brings me back to like, most of the questions I've had so far have ended up being like typo stuff. So super, super double check. Or in the case of like, that I will, when I'm getting a weird error on a field, I will just delete it and manually retype it. Otherwise, you won't like logically see the typo. Or there's also that moment of like, she did, I don't know if I talked about this or not, like have done like how people interface with computers kind of researchy things before. And if you're frustrated with something and walk away for 10 minutes and come back, you will have forgotten like the muscle memory of making that typo, and you'll probably not make it again. So walking away for 10 minutes and, I don't know, going for coffee or walk around the block or pet your dog or whatever it is, just do something else and then come back. That 10 minutes will probably have saved you 20 minutes of frustrated typing, banging on your keyboard, because you'll come back kind of fresh. So heads up, if you'd be surprised how much that actually helps a bunch. But that little trick only works if you're not doing it the night before it's due, right? So also a heads up as to that. I pushed the deadline out so that it's through spring break and whatnot. But that being said, do you suppose I will be Johnny on the spot with my email over spring break? No, I am bound and determined I am going to find a place to go ice fishing yet again. But I'm assuming the place that I find is going to be like far northern Minnesota, and I probably won't have cell reception where I'm going to end up. So it's not even like I'm ignoring you. I probably won't have it, because I will find thick enough ice to go out on and fish. So, because it's going to happen. So, yeah, I know. There's ice somewhere. Yeah, because the ice is open here, pretty much, isn't it? Yeah. That's not how I want to. I want to go ice fishing again. That's what I want. I might try that. That's actually my ice castle model is Lake of the Woods. But I don't think I'll be able to drive out on ice, but no matter where I find it. I mean, I probably can for a little bit till my truck falls through. But yeah, that's the goal. If I end up I'll probably go up to Fargo and then over, and I don't know if my auger's big enough to drill through like North Pole ice. So, but anyway, I'm determined to go ice fishing one more time. So I probably won't reply to emails so much over spring break. So even though you have the time, please don't wait until like the last minute. So maybe it's actually had me thinking of I gave extra time since I made that routing table mistake. I've kind of been thinking of I maybe shouldn't have done that, because all of you are going to wait until the last minute even longer now, right? Yeah. Yeah. That's how it goes. So, yeah, it was going to be due this Thursday, the 2nd. But I felt bad for, I don't know, the two of you that were trying to get it to work this weekend or something, and couldn't get it, so I wanted to give extra little fluff time for everyone. But please don't let it backfire on me, because we don't want that to happen either. So, any other assignment questions, or anyone else looking for ridicule? No? Okay. So, anywho, what we're going to talk briefly about today then is going through basically crawling up the OSI model. So we've been doing stuff, and this is usually if you've made a typo configuring your interface's IP address wrong, the first question, if that's what I suspect of you anyway, the first question I'm going to ask you is, are you ARPing? Does your admin machine or whatever machine you're trying to get to connect, can it ARP its default gateway? And if you reply back with it's not in the ARP table, well, your IP address is wrong somewhere. Because ARP is connecting, 2 layers? 2 and 3. So if 3 is botched, you don't get to play with 2, right? You're not picking your MAC addresses here. But if you've botched your IP address on layer 3, then 2 and 3 can't become friends. And for the OSI model to work, every layer needs to be friends. It's like a lasagna. You gotta have a good lasagna where every layer is friends. So we go up to layers 3 and 4, then at that point, that's where we're starting to talk about what things going on. 3 has got IP addresses. What do we have living at 4? We have ports and protocols and all that good stuff as we start to go up the stack, right? So as we continue, this is what I forgot about. I was going to talk about too. As we continue up there, there's other factors that come into consideration. Somewhat unrelated note, why would you make what's an egress deny rule going to mean? What does egress mean?
Leaving.
Leaving, yeah. If you have an egress window in your basement, what is the purpose of going through all of that effort of jackhammering a hole inside of the house? So you don't die in a fire, because in the event of a fire, you would like to ingress or egress your house. You would like to egress. That's the point of an egress window. If you don't know what an egress window is, it's like there's some basements, if you have an old house, that there's like a window that no way I would ever fit through. I usually claim my shoulders wouldn't fit, but there's probably other problems. So that type of window I'm not going to get out of in a fire. An egress window is going to be like sunk down into the ground, and from your basement you'd look out and see like retaining wall or something exciting and a dabble of sunlight. But in the event of a fire, you could open that window and crawl out of the basement, and it's not going to be a big deal. So same with egress firewall rules. It is for traffic going what direction? Out. Yeah, traffic leaving. So why would we deny traffic going out from a server network?
So we can tell, if it's like a web server, we can tell, okay, only set these things out. We don't need to be setting other things out.
Yeah, so like generally speaking, a server is not going to initiate a connection out to the internet, or shouldn't be, depending. Some servers will. So if it's an email server, is an email server going to initiate a connection out to the internet on its own? What's an email server need to do?
Like it's
Well, don't think of stupid like Windows Update stuff. Because I mean, this is a problem that just plagues Windows in general, that it's always trying to go out to the internet. But an email server, what's its role in life?
you have to send mail.
It's going to have to deliver mail, yeah. If you have an email server at home, at some point it's going to initiate a connection out to Gmail because you just sent an email from your account to Gmail. Your server needs to initiate an outbound connection. Those are generally the exception and not the rule, though. Does my web server ever initiate a connection out to the internet?
It does not.
No. Who initiates connections when it comes to a web server?
Somebody outside.
Yeah, like you do in your browser, right? When someone from the internet comes in. So a web server, a database server, stuff like that, these should never be initiating connections. If they are, there's something sketchy going on. Or they're trying to get Windows updates or something dumb like that. One or the other. So either way, egress rules for servers are a big deal because you can actually find bad things going on. You will also find Windows trying to get updates or certificate CRL lists, revocation list updates. But anyway, there's that when it comes to firewalling. So yeah, if we end up with like your web server had a vulnerability, I'm able to pop it and put some kind of malware on it and spread around. When that malware tries to phone home, I want to see it phoning home. That's why we have egress rules going on. So I'm going to come back to this DNS thing because that's going to become relevant here in a second. So what it comes down to is, no, let's talk about this. So if we go here, DNS or UDP53 should be used for what? Should be using for DNS requests, right? That should be whatever, your computer or a server or something asking like, where's the domain controller at? I need to know its name or something like that. That's what's going to happen. Or if you're browsing the internet. At any point, should a UDP53 be used to transfer files? No, that's not normal, right? UDP53 should just be for DNS traffic. So what this person has actually created is a PowerShell script that does file transfers via DNS. So this is where, when we look at our like standard firewalling, can we tell what's going on with just normal firewalling, like layer 3 and 4? No. So that is where we're in a bad state, because we track what you're doing as far as like the firewalling we've done so far. we track applications by ports. So if we want to allow web applications through, what's the port? TCP/80, right? So it doesn't matter what it is. If it's a remote desktop, 3389. Like every application has some sort of default port on it. So and that used to work, and it still sort of does a little bit. But it doesn't work because we can start doing like all sorts of crazy stuff. So let's say, yeah, here we go. Did I tell the story where DSU used to block remote desktop going out for some reason? It was a different network admin ago. But for some reason, outbound or egress TCP 3389 was blocked at DSU. I don't know why. It's not anymore. So if you wanted to remote desktop to your computer back at home, you couldn't do it because we blocked the port. So in the case of DSU, we did allow HTTP traffic out to anywhere. So what's a solution around this if you really want to get it to work? Yeah, you could, using NAT, or like from DSU, actually NAT the port. So you could do something like take port 80 on your public IP address and send it to port 3389. So when you'd actually use the, do I have it remote? Desktop, yes. Let's look at it and add something. Here we go. I would go like 1.2.3.4, and by default it's going to use port 80, but instead if I do something cool like, or it's going to use 3389, but if I go :80, that's our universal sign of telling an application to use this port instead, and generally they'll respect that. So doing this, since at the time DSU's firewall was just our standard issue normal firewall, checking IP addresses and ports, what would we see going out, or what would we claim you're doing? You're browsing the internet, right? You're just browsing a website. Probably a web browser connecting is what we would say, because it's TCP port 80 going out. So that doesn't work anymore. So what we need to do, the new version of RDP will switch over to UDP stuff for some things, yes, to try to improve like performance, make it nicer rather than using TCP. But if it's blocked, it will just still use 3389. Yeah, and that's why this story works better in the DSU of 4 years ago or something, because back then remote desktop only used 3389, whereas now it'll actually try to use a couple other ports too. But yeah, you bring up a good point. So, anywho, we need to watch what the application's doing a little bit deeper. So when we look at what this is called, this is where, you ever played Buzzword Bingo? It's a fun game to play when there's like cyber analyst on CNN or something like that. They're going to see how many buzzwords, like hopefully you don't win unless you got cloud and cyber and advanced persistent threat and I don't know what else. But stuff like that. So when we're talking about these are all of our buzzword bingos going on. So if we look up, I'm pretty sure the Palo Alto, like the website is going to be like, look at our NextGen firewall. Like, okay, whatever. Either way, all of these are doing the same thing. But if we have this is my favorite, is the waffle. If you see a web application firewall, what that really is doing is, because that's actually a new buzzword bingo, is just web application firewall. It used to be more complicated, but what that's really doing is doing everything we're talking about here, but just for web application stuff. It's not going to identify other traffic. So this is like a situation that the sales guy or gal is going to be like, wow, you're doing that? That's all terrible. You need the NextGen firewall. You know, you're terrible. You need to buy more things from me. So you get to abuse folks, because a lot of times salespeople may or may not understand that they're talking with a technical person. They think it's just like a like a decision maker signer of the budget. So that's where buzzword bingo comes in. So that's usually like when I'm talking to people about the IA lab or something like that, or related things. I'm like, we can have this conversation, but no one can say cloud. Cloud is strictly forbidden because that's the first thing. It's like, well, it's a private cloud environment. And I'm like, no, what is it, right? Same with this. NextGen firewall. I'm like, no, what is it? Is it just inspecting layer 7 of the packet? Well, I mean, I don't know. And they don't know the answer to the question, then you know you're not talking to a technical person. So if we look at an application filter or next-gen firewall or whatever, what we're actually doing then is looking at, we're actually, depending on the firewall, you might not even be looking at ports anymore. Like in the case of like the Palo Alto thing, we can actually configure a firewall and never define a port at all. We could just define HTTP or web browsing is what's allowed on there and never actually specify the port. The firewall is going to make some assumptions. But either way, what it's going to look for when we receive a packet is when we see things that look like post or get. Where would you see post or get? Well, you'd probably see get first inside of a packet, especially on port 80. What's that probably going to be?
Trying to request something from the web server.
Yeah, that's the command. If we open up in Wireshark and browse a website, the first thing that you're going to see is the get command. Well, it might have a protocol version or something, but it's going to say get. I want to get this file. So if we see get, and we see the server replying back with like 200, what is 200 the generic number for in status code lingo? Do we have to go down this road? I mean, if we got to do it, we got to do it. 200 means all is well. Yeah, 200 is our status code for like a server. It doesn't have to be a web server because everyone else adopts these codes too. So not everyone, but a lot of places do. So if we see a GET request and then the reply packet has like 200 and some file in it, there's some other assumptions we can make, but there's probably a pretty good assumption that that's a web server. If we saw something like this inside of the packet, standard query A, and this is more easy to visualize if we actually opened up Wireshark, but regardless, if we saw a text like that, standard query A, any guesses as to what that would be? If we talked about an A record, what's that? DNS, yeah. So if we see this language inside of a packet on port 80, is something mismatched all of a sudden? Yeah, something's not right. So at that point, can we determine that the application talking over this port, is it now valid? If it's doing standard query A? Now we can see something's gone wrong. Or same thing if over UDP port 53 or TCP port 53, if we see a post or a GET request going through, that's also going to tell us that's not DNS because that protocol doesn't look like that. So that is where we see many things on like the fail board or the wall of sheep. So depending on how nefarious you've been, when you've gone somewhere that wants you to pay for Wi-Fi, they often allow some sort of traffic out. Usually what they actually will allow out is DNS traffic. So they'll allow you to connect out and get the real IP address for Google. Then when you try to go to it, they'll intercept the traffic on port 80. And that's all they look for is port 80 traffic and intercept it and redirect you to the page that says what?
Please log in.
Yeah, please log in, or like, please pay for the GoGo instant Wi-Fi or something like that is what it's going to tell you. So oftentimes, those sort of captive portals, if you just set up like a proxy somewhere that runs on a different port other than port 80, you just go browse out to the internet. Or if you actually have a web server you've stashed somewhere that lives on port 123 or 53 for that matter, you can browse to it, and the captive portal is never going to see it because they're misconfigured and they're not actually inspecting and looking for web traffic. They're just looking for traffic on port 8. So in the end, what this means is our generic, like, 99.9% of the people on the plane or in the hotel or wherever it is pay for the Wi-Fi, whereas the rest of us that know what a port is can usually find ways around it. Not that that's what I'm, like, encouraging you to do, but because that's, gray area. But you can actually start to get around a lot of these things and get out on the internet without actually being approved through the system. So what we usually see in here is interpreting, like, the actual contents of the packet. So how many of you have gone to a school where, like in high school or something like that, or wherever, whatever level, and if there was a swear word on the web page, it would be blocked, right? That's a pretty easy find and replace to do. If we see a packet coming back from a web server, we just search it for an F-bomb and be like, nope.
Interesting story about that. We had a restaurant in my hometown called Diego, and apparently that's the slur for Italian American. And one of the teachers tried emailing and saying, yeah, well, after whatever, we'll eat there later today. And her email got blocked because of that.
Oh, sure. So we learned, similar to like when we did like harassment training things at DSU, like pick up on, people harassing each other, being mean. I actually learned things like I didn't know that like racial slur existed. I didn't know it was a thing. So yeah, same with the restaurant name. Like who knew, right? Yeah. So these are doing pretty basic stuff. Like it's basically just doing a text search of every packet that comes through. So if we look at something like this, who is a regex master? Regular expression. Yeah, no one ever is, or if they are, they wouldn't admit to it. But
HTTP with regex?
yeah. So in this specifically, so in this particular packet, if we look for regular expressions, it is looking for HTTP and then connection with content type and stuff like that. So what is this really looking for? Or what is this expression trying to identify? Yeah, it's trying to identify web browsing. So immediately, like if we see this regular expression matches true on any of our packets, we can roughly assume that someone's doing something like web browser-esque. If that's showing up on a weird port, we can start to see like, there's something sketchy going on. If you go to L7-filter.sourceforge.net, you can look up. Now, mind you, this isn't like not something that's highly maintained. How about that? So, but you can come on here and find regular expressions for a lot of stuff, and they have like a rough scale of what is it? It's some sort of confidence interval. Oh yeah, here we go. Green works great. Red probably is a broken regex. So either way, we can come through here and you notice there's not a ton of greens, but let's see. POP3. What's POP3? Yeah, it's an email protocol for you to download messages from the server. So, wow, really complicated regex here. When we actually search through this and find the text, what's it looking for? This is the only uncommented line. So it's just looking for POP3. So, I suppose it's not like other protocols are going to use that specifically. So we can start to identify all that stuff. The other thing you notice is the speed in which they're processed. So this whole library of stuff is what pfSense used to have in it for doing layer 7 packet, like deep packet inspection kind of stuff. pfSense has since gutted it and removed it. So like, nope, this feature sucked. We're removing it. If you pull down the old version of pfSense, you can still use all these. But they've since removed it altogether. And there's a reason for that. So what's an IDS? What's IDS stand for?
Intrusion detection system.
Intrusion detection system. How about IPS?
Intrusion protection system.
Prevention. But yeah, so, and it's kind of one of those fun things. So IDS, intrusion detection system, is basically like back in the day, if you had an IDS running, you would more or less create these regular expressions that identified like a piece of malware. And it was great. It would send you an alert when it detected traffic that had a piece of malware on it. Would it do anything else? Nope, it would just notify you like, you're hosed. Smile, carry on your day. Whereas an intrusion prevention system would actually try to actively stop the traffic in some way. So there's two different engines that you maybe have heard. We probably heard of one. We've heard of Snort. Hope you've heard of Snort. So related cat, because what's the logo for Snort? It's a pig, yeah. I actually have some stress ball pigs down in my office from Source Fire that is like the maintainer of stuff now. The other one is Suricata, which is just a different one. They can each eat each other's rules. So in the case of pfSense, they removed their Layer 7 inspection stuff because they said, well, hey, Snort's doing the same thing. And in case of pfSense, you can install Snort on pfSense, but you can have it like inline sort of thing so that it's not going to just be an IDS or detect stuff. It's going to actually evaluate the signatures and be like, ooh, this matched a regular expression for something sketchy. I'm going to drop the packet. So that's where we get the intrusion prevention system. So when we keep going on, that's where like firewall vendors think they're cool now with their NextGen firewall, because now not only are we just looking at ports and we're not just having Snort run over on the side and send alerts, what we're basically doing is taking all of those regular expression-y matching things and putting it inside of a firewall rule. So that's where inside of the Palo Alto VM, when we were making rules, there's lots of other options that we just skipped over for right now. Like you could block Facebook chat and just that, but still let the regular Facebook work because it has a signature that matches like the actual chatting part of Facebook or Facebook video or something like that. So that's where we're coming to. Why? Any idea why we're bringing all of these into one box now, and why we didn't do it before? It is easier to manage now. Well, it can go either way. Usually, it's easier to have like one box and one place to configure stuff. But if we think about what's the downside to doing this regular expression-y stuff? Yeah. So the reason why we wouldn't do this before is because when we would take Snort and analyze network traffic, what we would actually do is copy the traffic. We wouldn't say like it has to come in this interface on Snort and go out before you get to the internet. We would say you going to the internet, you go from you to router, and then the router will have a mirrored port or a copy of all the traffic, and we'll pipe that into Snort. So we'll then let Snort alert us, and then if we see something sketchy going on, we will either go look at your computer, or if we were really, really fast or really, really cool with it, we could go into Snort and say, when we have an alert for some nasty kind of signature, instantly make a firewall rule to block it. It would still take a second, but it would sort of kind of work. So the reason why they're split out, though, is because if Snort was bogged down or overwhelmed by a lot of traffic, we didn't want to slow down the network's throughput. So if we have to analyze every single thing, if we take this firewall, for example, which is what DSU at the edge, we have 2 of these running. This firewall right here has 4 SFP plus interfaces on it. Any guesses as to how fast an SFP plus interface runs? Yeah, 10 gigabit. So this firewall has 10 gigabits of interface goodness right here, plus however many, like a bunch of gigabit ones right there, and then these are just regular SFP interfaces here, I think. So either way, there's 40 plus, I don't know, let's just guess that this is 20. So there's 60 gigabits, or 60 gig of ports on this. This firewall, just identifying the traffic, So just looking at the traffic and being like, that's web traffic, or that's email traffic, or that's YouTube. Doing all of that alone drops our 60 gigabits of ports down to like the most traffic you will pump through our firewall will be at a rate of 10 gigabit a second. This has a very fast processor and it can do lots and lots of stuff, but just identifying what the traffic is slows it down like a sixth. We can only process stuff that fast. If we go even further and actually start not just identifying traffic, but basically kind of like start antivirusing our traffic. What's antivirus do? What's that?
Scans your whole computer, looks for baddies.
Scans your computer, looks for baddies. And how does it do it? What is its way of determining that like a piece of software is bad? Yeah, it's a definition list of signatures. So if we go a step further, it's one thing to identify the evils of Facebook video or something like that. But if we go a step further and be like, we want to detect, I don't know, an MS-08067 like ghetto attack from the internet. If we want to not just identify traffic, but we want to identify specifically malicious traffic, that's a whole nother batch of signatures that we're going to start applying. So that takes us down to 5 gigabits that we can send through this. Now mind you, is 5 gigabits a slouch amount of bandwidth or throughput? No, that's quite a bit, right? Like our primary internet connection is not even quite that fast. It's close, but it's not quite that fast. So 5 gigs is like, we're not slowing things down here by that, but actually the box does have a maximum in the amount that it can actually process. So definite downsides to that. But the cool thing that this then does is lets us identify maliciously acting or looking traffic along the way. So when we look at, I turned the usernames off because I was like kind of prepping this before class, and I actually found someone's computer's infected. So I hid usernames off of this. So when we look at DSU's firewall, we have our log of all of the traffic going on, and this is, what is it, 1021? Yep, this is current. So general looking firewall log, right? We have time. What did you do? This was drop traffic. Where's it from? The untrust zone to the trust. So what does that mean? What direction was this traffic going? Outside to in, yeah. And you can actually look at outside ingress block all. So this is just generic like crap traffic from the internet. Notice port 23. So what this probably is a webcam looking for other webcams or something crappy like that. So to make things more interesting, let's go trusted. And yep. It's not case sensitive. That would be silly. There we go. So my overall comment about these is while it is a nice firewall, it's meant to be a nice firewall. They didn't do so much on making the interface fast. But it is what it is. So there's some basic guesses we can make. If we have something coming from the inside network, which this looks like student traffic, or like wireless traffic, just because I coincidentally know what that subnet is, going to, guess what 64 or 138.247.64.45 is, and 40. Those are our domain controllers at DSU. So what kind of questions are we asking on port 53? Yeah, it's actually doing DNS queries. So I wonder if we could do, the application is not equal to DNS on port 53 if we find anything. I don't know if we will. Interesting. So there's something it wasn't able to identify going out. So I would say, I'm not going to open that because it's going to show a username and I don't want to do that. But I would venture to guess there's something weird going on, or someone has like some sort of sketchy, like getting around a content filter sort of thing going on, is my guess. The other one is apparently, what's Sophos Live protection going to be? Yeah, it's an antivirus company. Now, I don't know why in the world they're using port 53, but, I mean, you know. Exactly. You know, it's on port 53. You'll never find us. So there we go. We have a couple. Oh, there's a few. A few machines that are actually, you know, going out there. So if we go, instead of 53, let's look at 80. And we should soon find out why it does take a little bit. So there's web browsing going on over 80. Find any other exciting things going on over port 80? Let's look. There we go. So I'm going to get rid of these incompletes too, because those are usually just dropped requests or something. There we go. So in addition to being able to just identify browsing the web, we can go even further down to like your Twitter client is going out for a refresh, or specific Pandora traffic. Because does Pandora necessarily need to run in a browser? No, where else can Pandora run? As an app, right? Everything can be an app now. So looking for specific like web browser fingerprints, that's not necessarily going to be good enough. So we actually have to go further in and start to figure out what's going on. So Twitch, HTTP, so there's video going on. Lots and lots of Google users. Good stuff like that. Let's go a step further, and instead of saying allowed traffic, let's look at what we're blocking. Oh, nothing over port 80. Here's a good one. Does anyone know what's actually blocked here at DSU?
Possibly EVP ports 500, 1701, and 4500.
That happens to be the ports used by your VPN that you can't get to work?
Yes, sir.
There we go. So what is the one application? There's two applications that we do block going outbound. BitTorrent, yeah. Why would DSU block that?
You can use that for legit stuff.
You sure can. But guess what 99% of DSU students use it for?
Resilio sync and sync all their files.
Yeah. So BitTorrent, and there's ways like, I'm not saying that the Palo Alto signature base is like the most 100% way of doing that. There's easy ways around it. If you're smart enough to figure out ways to get around it to do your 100% legitimate BitTorrenting work, we figure if you're doing that, you're probably not going to be generating DMCA takedown notices against the university, because you must know what you're doing a little bit. So that's kind of one of those, like, a lot of people may or may not be running BitTorrent at home for 100% legitimate uses, and then come to campus with the same client open and be sharing out legitimate content, of course, to the internet. Every once in a while, something might sneak in. You accidentally, loaded a file that maybe was copyright protected or something like that. So the university starts getting takedown notices or DMCA notices. So we got tired of that. And instead of going and having a talk every time, do you care? If DSU has a talk and tells you to stop pirating things, are you going to stop pirating things? No. Maybe you'll consciously try not to do it when you're here on campus. But if you take your laptop home and you're pirating things at home, then you come to campus and forget to close your BitTorrent client, it's going to start up again. So once you have they have some sort of a so many strikes policy. So eventually we're like, okay, we don't want our students getting sued because DSU is just going to pass on all of the legal love to you. So we're like, it's easier to just block BitTorrent. But what's hard to block about BitTorrent?
Uses so many.
Yeah, you can't block the BitTorrent port because there isn't one. That's the resiliency of BitTorrent, is that it it's able to move around and be on all sorts of different ports. Generally, if we look at the port like this particular one, 54749, what would we assume that port to be?
Ephemeral port.
Yeah, it's an ephemeral port. Do we block ephemeral ports?
Now you do.
Well, we do, but do we have a list of the ephemeral ports we're blocking? No, we just look again at the signature and be like, hey, that appears to be BitTorrenty traffic going out, so we just drop it. We do coincidentally log the port, but that's just a part of the log.
How many logs does this thing generate per day?
A lot.
How far back do you keep it? This has like a lot of space.
It does. So I have a Splunk indexer, which we'll talk about Splunk soonish in class. But if we go look, so the amount of traffic we're generating, whoops, I was not going to do that. I was going to go, easiest is probably just look at licenses. Licensing, there we go. So for today, our firewall has generated around 4 gigs of logs. Not 4 gigs of traffic, but this is 4 gigabytes of log data.
That's just from midnight today?
Yep. Starting at midnight today until now.
What happens when you hit that? Is that 10 gigs? Is that a limit or what?
Yeah, then I start getting all of these notices of the pool is over quota every single day because we exceed, the license I have is only for 10 gigabytes of data to index, and we're exceeding it every time. So a couple cheap ways that we can fix that is like the majority of the hits that we deny on our firewall are from telnet, from the outside. So I'm working with the IT department, just be like, don't log that. Like, well, we want to log everything. Like, you don't care. We're not ever going to let telnet in, so just don't log it. We just don't care about that data because that's not relevant to us, right? So a lot of stuff like that, or just port scans and stuff like that. There's no relevance in us logging that kind of data. This is more, well, I don't really care about the BitTorrent thing either, but the allowed traffic is kind of more relevant when it comes to finding out what's going on. As far as how long we keep it for, I got a lot of storage. So we'll keep the events for quite some time. But yeah, so that's another foreshadow of kind of where we're going to start going next. And this actually ties into your, we'll start to tie into the textbook more. The textbook doesn't like Splunk because it's very, very expensive. So they use an open sourcey kind of thing, but we'll adapt a little bit. Actually, like the logs in this interface, while helpful, our firewall, the actual firewall itself, I think can only handle about 3 days worth of this data, and then it overwrites it because it only has so big of a hard drive inside of the firewall. That's why it's being pushed out to Splunk. So the data here in this interface is one thing, but being able to actually search and find correlations of stuff, or see like you're consistently trying to go to this particular IP, or how long has this computer been trying to go to this malicious IP kind of thing, to start to track like how an infection came in and was spread. There's one other thing. Oh, yeah, this one.
Mail servers here?
Not actually mail servers themselves. Well, no, you can't run an email server at DSU. You can't like, oh, there's only been one blocked in there. Oh, no. There we go. So this is outbound traffic to SMTP. So yeah, I guess that would partially be sending mail or running a mail server. What else could it be that's kind of annoying that gets blocked? So it could be like if you use Thunderbird or Outlook to connect to Gmail, that when you send the message, there's potential that that will be blocked because that is an outbound message through SMTP. Why would DSU, or not just DSU, potentially, depending on who your internet provider is, they might do this to you too. Why would the world block outbound SMTP? Yeah, like one of the favorite things of malware, like there's a hit list of favorite things for malware to do when it gets on your computer. One is to encrypt your hard drive and hold you ransom. That one's pretty simple. The next one is to scan for all of your files and steal any data that seems interesting, like social security number, credit card. Yeah, that one's also pretty simple. The other one is to just turn your computer into a part of a botnet. And that's a little more complicated. You require infrastructure for that. But a good chunk of botnets in the world are generating what kind of stuff? Spam, yeah. So, or Windows updates. So, in the event, and I'm not to say that these are all computers that are infected with malware, but they could be. I don't know. Well, I'm going to assume this one is. So, one of the things when your computer is a part of a botnet is that it's probably going to be one of those devices that spams out. And that's where we'll get things like I'm going to open up my spam. This is going to be a treat for everyone. See what we get in here. So, waiting. Ah, yes. Here we are. Secret Israeli military experiment leads to cure for hearing loss. Obviously. So from the particular spam thing, I can't get to the mail header. But if I looked at it, this message, was it probably relayed from a Gmail server? I think Gmail would send a message like this. Or Google would scan their account or scan systems and be like, nah, it seems like a sketchy message. This probably, if we looked for it, comes from a residential internet provider's IP address. Why? Why would it do that?
Because it's probably less restricted and somebody's infected.
Yeah, it's probably someone's computer at home that's infected. Whereas if DSU found out that our main mail server was compromised and sending out spam, why would we care other than we're being annoying?
You get blocked.
Yeah, there's email blacklists out there of email servers. Slurp's not it. Slurp is something else. There we go. So when we detect, like, someone reports that, hey, this particular IP address is a source of spam, you get put on a blacklist. Now, if that's your IP of your residential internet, is it really going to impact you much if you're on a blacklist? No, you're not going to notice. Your life will be fine. I mean, aside from your malware infected and spewing and all of that stuff. But aside from that little nugget, you don't care. If it's a production email server like DSU and we get put on a blacklist, many internet providers or email service or servers are subscribed to these blacklists. So when our IP address of our mail server or the dsu.edu domain shows up on that list, what's going to happen to your message that you sent to your mom or dad at work? Work's email server is going to look and be like, oh, that IP address that is DSU's legitimate email server is on a blacklist. I'm not even going to look at it. I'm just going to dump it. So you'll run into email deliverability issues. So that is where DSU blocks outbound SMTP, because we don't want our net block showing up on a blacklist altogether. And that is a frightening number of machines. Well, no, it actually looks like it's 2 or 3 machines showing up on the list. And I'm pretty sure 104 is the student wireless. So when I refer to the wireless network as being a cesspool of things that you all bring from home, that's why. Because there's clearly sketchy things going on there. So there's also other fun things like, in the case of our firewall, we do have the threat protection turned on. So when we look at this, this is again going to be fairly like, I get these messages all the time of SSH login attempt. So something is really trying to log in with SSH, probably brute force attempt, to this IP address in the IA lab, which I'm pretty sure doesn't even have anything on it. Like, that IP address doesn't exist. But we still see the SSH brute force attempts coming in at it, so we're logging stuff like that. The other one is configure. That's probably the most popular one that we get. But either way, this is what would actually slow down our throughput, is in addition to mapping what the application is, which is something that we can kind of do after the fact to a certain extent, as far as like in terms of processing traffic, this we have to do up front. So we have to make sure, like, hey, you know, what have you got going on? Looks like this is doing a port scan. Yeah, all sorts of good stuff. So there's, if we look at the, like, there's a risk level that it associates with all of these. We can do like medium, high, extreme events and stuff like that. But anyway, that is all kind of our primer as to why we're not going to like really sit down and write snort rules. We'll look at some traffic inside of Wireshark and kind of see how we can identify it eventually when we get in class. But why are we not going to sit down and learn how to write, you know, extensive snort rule libraries? A lot of them already exist, so Snort puts out a ton of rules for free. You can then pay what they actually do as far as Snort's concerned, and I'm sure Palo Alto is bringing in Snort data, but what they do when Snort publishes a set of rules is they delay the free public release by like 2 weeks. So if there's some hot new 0-day going out and attacking things, if you're just not paying anything, just getting free Snort rules, you won't get the definition for that for a couple weeks. Or if you pay a marginal fee of some sort, then you can get them as soon as possible. In the case of DSU, Palo Alto has their own subscription threat feed kind of thing that our devices subscribe to, and we're pulling in updates for that like on a, I don't know, so it's like minute by minute basis or something like that. It's hammering out, checking for updates all the time though. So the reason why we aren't going to sit, and maybe we probably will just for fun to do it, but the reason why we're not going to go through like, here's how you'd make an extensive library of rules to identify traffic and Snort is because realistically, when you got into the world, you're just going to pay someone else to do it. Because there's no way you're ever going to be able to create the rule set that's as extensive as either Snort or Cisco or Palo Alto or Juniper, whoever. Like label any vendor. Theirs are going to be better than what you write. So unless there's like some very specific thing that you have going on, then you might write a rule. So that is what we got for today.
Back to that spam email.
Yeah.
At the end of it, it had like some garbage characters. Why do they have those?
Oh, on mine?
Yeah, like a TM and
Yeah.
do that. Like that's extremely common as far as I can tell. I look at spam emails.
I would say this was either an encoding problem of like this could be an international thing that didn't have the correct character sets, like it wasn't using like our Western Unicode or whatever. That could be one reason. Or the other reason is there's like general algorithms for detecting what looks spammy versus like a newsletter. And a newsletter might have, if it's from like a company, it might have a trademark symbol in it. So this is its like ghetto way of trying to get around it. I'm guessing since the message is just cut off, is it it's an encoding problem and the session got dropped? Or could have just been a crappy internet connection that lost its connection midway through delivering the message. We find smarter way to buy a mattress. Here we go. Oh yeah, these are all cut off. Qatar Petroleum Investment. Interesting. Let's see. Oh, there's a symbol there. Oh no, not gonna open that one. Oh yes, exclusive Trump offer. The other one is that these probably have embedded images, but this web interface isn't going to show them to me until I deliver them. So why you and your, yeah. So why do your email clients block images from being downloaded by default, hopefully?
Well, stuff is usually embedded inside pictures.
Yeah, so we could maybe embed something nasty inside of a picture. That's one thing. But the other one is, as soon as if I send like an HTML message, have you ever heard of a tracking pixel? It'd be like a 1 pixel by 1 pixel, just non-existent image that I can hunt you down with. So if I embed a tracking pixel inside of there, when you open it up in your email client has to go and get that pixel or all the images from me. So I can actually track that you opened my message. So if I know you're opening my messages, then I can hammer you down with more spam. Is kind of the idea behind it.
Good email providers like Google started opening that stuff on their side so that people can't.
Yeah. I mean, it's like if you're using Outlook and you download the pictures inside of the message, then you have engaged the tracking pixel. And if you ever get anything that's a marketing message, I promise there's a tracking pixel in it. Because there's no way they'd send out a marketing message and not track what you're doing with it. I mean, come on. So, anywho, that's what we got. Yeah, I'm guessing this is either text that's at the top of the message and then the rest of it's an image, or it's getting cut off, or something like that. Or maybe this mail marshal just cuts off the message and doesn't display the whole thing. It could be too. So, anyway, stay tuned for what we'll be doing next time, because I'm still not sure.